Okay class, now let's proceed to the properties of the Laplace transform. The first one is the linearity properties. Okay, the linearity properties state that if you have two functions, then you want to Laplace that function. For example, you have the function, let's say the combination between the function of f1 and f2, and then you want to Laplace it. So you can Laplace it separately by considering what is the constant you can put outside, and then you will have the Laplace over here f1, and then you will have over here the Laplace of the f2. Alright, okay, so now is actually you may separate it and solve it separately. Okay, let's say if you have, okay, I put one question over here. Let's say you have the function of ft, and then that ft we have the t squared minus 1, and then we have squared over here. So the easiest way to solve this one is actually you may expand this one. Alright, if you expand this one, so you will have t squared minus 1 multiply with the t squared minus 1. Okay, and then what you will get over here is t power of 4 and minus 2t squared, and then you will have plus 1 over here. So now you need to Laplace the function of ft, and then you need to Laplace each term over here. The first one is t power of 4, and then the second one I directly put the constant outside, and then you will have to Laplace the t squared, and then final one you need to Laplace the terms 1. Okay, so when you Laplace the ft, you will get fs. Okay, what about this one? This term you will have to identify what is the value of n over here, because we need to have a n factorial, and then we have s n plus with 1, so we have 5 over here, we have 2, and then you need to consider to Laplace the t squared. So what you will have is 2 factorial, and then you will have s cubed, and then for this one you will have 1 over s. Okay, so now this is the time to simplify. What is the 4 factorial over here? The 4 factorial is 24 over s5, and then 2 factorial is 2, you have 4 over here, and then this is the last one, 1 over s. So this is the answer. Alright, okay, let's go to the second example. Okay, the second example, if you have to Laplace the expression that having exponent, for example, plus with one hyperbolic function, let's say sine hyperbolic 3t, and then we have 1 sine t, and then let's say we have minus with cos half t. Alright, okay, so now if you want to Laplace each term over here, so what you will get over here is this term you will have 1 over s plus 2, and then the sign over here, the things that you need to consider is the 3 over here. So we have for sine is plus a is 3, and then we have s squared. Since it's hyperbolic, then it will be minus over here, so it still have 3 power of 2. And then this one we have sine, then a is 1, so we have 1 over s squared. Since there is no hyperbolic, so it's plus over here plus a is 1, And then for the last one, we have cos. And then cos, we have s over here. We have s squared over here. And then your a is 1 over 2 since it's cos. So it will be plus over here 1 over 2. And then this one should be squared. So is it everything already in the simplest form? This one, yes. This one, and this one. So everything is in the simplest form. So this is the answer that we want to find. Okay, let's go to the first shift theorems of the Laplace transform. The first shift theorem tells that, okay, if you have the function of t that combine with the exponent, and then you will get the function after transforming f and s minus a over here. So in these functions, what you need to understand is you need to understand or able to identify what is the value of a. Okay, so for example, if you have one question, exponent negative 3t cos 4t. Okay, so in here, so you know that you will get an a over here, which is a is equal to negative 3, right? Okay, so is a negative 3. So this is your a. All right, this is your a. Okay, so now your ft is cos 4t. So from the ft over here, you will get your fs. So what is your fs? According to the table, what you will get is s over s squared. Okay, s squared plus with a for squared over here. However, if you want to solve the exponent negative 3t cos 4t, so your answer must be is in terms of s minus a. So your s now is negative 3. So you will get f s plus 3. Okay, so the answer for the Laplace of exponent negative 3t cos 4t, you will get is for this one, but in every s, you must plus with 3. So you will have over here, and then you will have over here. So this is the answer. Okay class, now let's try another example. If you have one question, and then that question is combination of the exponent, let's say 2t, and then with another ft, which is, let's say I take it from the polynomial t power of 3. So in here, what you need to understand is you need to find what is your a. So this is your a, right? A is 2, and then your ft. So your ft is t power of 3. So directly from the ft, you will get the fs. So the fs over here, you will get 3 factorial and then s power of 4. Okay, so the answer according to the first shift theorem, you will get your answer in terms of f s minus with a. So your a is 2. So the answer you will get over here when you taking the Laplace of exponent 2t t power of 3 is, you just take it the fs, but in every s over here must have the s minus 2. So you simplify the 3 factorial, you will get 6, and then for the s you will have s minus 2 and the power 4 remain here. So this is the answer. Okay class, let's try this example. Okay, as previously, you need to identify the a. The a is 1 over 2, and your ft is cos 1 over 2t. From the ft, you will get your fs. You will refer the table. For the cos, what you will get is, you will get s over s squared plus with 1 over 2 squared over here. Okay, however, for the first shift theorem, your answer must be in terms of f s minus with a. Your a is 1/2. So the full answer for the Laplace exponent 1/2 t cos 1/2 t over here is s minus 1/2, and then you have s 1/2 over here squared plus 1/2 squared. Okay, it's very easy, right? Okay, good luck.